Keeping with the theme of exploring real-world lessons in recommender systems, let's do a deeper dive into a couple of case studies from two of the best-known recommender systems out there, YouTube and Netflix. Let's start with diving into how recommendations work with YouTube. YouTube is now owned by Google, and given Google's obsession with deep learning, it shouldn't surprise you that YouTube has gone all in with deep learning to power its recommendations. A nice thing about Google is that they publish a lot of their research and open source a lot of their internal tools. As a business person, I'd criticize them for enabling their competitors, but as an educator, I think this is a wonderful thing. They've made the paper Deep Neural Networks for YouTube Recommendations freely available, and it goes into quite a bit of detail on how YouTube recommendations work. Not only is this a treasure trove of insight for researchers in recommender systems, but it also contains valuable information for people trying to optimize their own YouTube channels. Let's go over some of the more interesting points in the paper. YouTube has some specific challenges, so keep these in mind before you decide to apply what they did to your own problems. If you don't have the same problems, the same solution may not be the appropriate one for you. The first issue is scale. YouTube has well over 1 billion users who watch 5 billion videos every day. That's just mind-boggling when you think about how many users and items they have to compute recommendations for. Anything they do must be horizontally scaled and distributed on a massive cluster, and must be vended to the users extremely efficiently. The next is freshness. Over 300 hours of video are uploaded to YouTube every minute, and their recommendations must take into account both newly uploaded content and up-to-the-second data on each user's individual actions that might indicate their interests right now. They must strike a deliberate balance between recommending well-established videos and new content, but they clearly favor new content. The last big issue is noise. Most of their interest data consists of implicit ratings, not explicit ratings. As we talked about in the previous section, implicit ratings data is fraught with peril. Just basing recommendations on which videos people click on creates a system that's subject to gaming, and in the words of the paper, unobservable external factors. Someone clicking on a viral video isn't necessarily an indication of the ground truth of that user's interests. Their data is also extremely sparse, and the content attributes associated with their videos is, quote, poorly structured without a well-defined ontology, unquote. That's YouTube's polite way of saying that the data they're working with is a real mess. Based on their results, it seems they've done a good job of overcoming these challenges. When I visit the YouTube homepage, it comes up instantly and includes recommendations that do an excellent job of capturing my current interests. Google has gone all in with deep learning, with a mandate to use it for nearly every machine learning problem they encounter. I can understand why they did this. It allows them to focus all of their engineering effort on deep learning frameworks and use that as a general-purpose tool for use by the rest of Google and its child companies such as YouTube. So in 2016, YouTube moved its recommendations to a deep learning framework powered by Google Brain, which today is called TensorFlow. Previously, their approach was based on matrix factorization, which we've also covered. As we've mentioned in the course, you can implement matrix factorization with a neural network, and at first that's exactly what they did. But over time, their approach evolved beyond matrix factorization.